Hello, hello. Welcome to day 3 of our unit. Today we're talking about solving by substitution. And when we solve by substitution, the thing that we need to focus on is the idea that we're substituting one variable in for the other. So here's an example to get us started. We've seen this before. It says solve the equation when x equals 7. So what I'm going to do is anytime I see an x, I'm going to substitute in a 7. So I have negative 2 times 7 plus y equals 10. Well, negative 2 times 7 gives me negative 14 plus y equals 10. Add 14 to both sides, and y equals 24. Well, I just solved that equation using substitution. So what we're going to do today is now apply this to systems. So here are my steps. The first step we're actually not going to really get to today. Today, everything in step 1 is going to be done for us. What step 1 says is solve one of the equations for one of its variables. Meaning, I would have my two equations, and I would solve one for one of the variables. Well, if I look, my second equation is already solved for y. It says y equals 2x plus 1. So step 2 says substitute the equation from step 1 into the other equation. Well, the equation that's already solved for is y equals 2x plus 1. Well, that's kind of the same as the idea as y equals just some number. I'm going to do the exact same thing I did on the first slide, and I'm going to put 2x plus 1 in for y. So anytime I see a y, I'm going to put the entire piece 2x plus 1. Let's see what this looks like. X plus, well, it says x plus y equals negative 2. Instead of y, I'm going to put 2x plus 1 equals negative 2. So what I just did is took my first equation and I plugged in what y equaled for my second equation into equation 1. Well, now I can solve this for x. I have x plus 2x plus 1 equals negative 2. If I combine my like terms, I get 3x plus 1 equals negative 2. Well, if I subtract 1, I get 3x equals negative 3, so x equals negative 1. Well, I just solved for one of my variables. That was step 3, solve for the first variable. I just solved for x. Well, step 4 says substitute the answer, this answer, into the other equation. So the equation I didn't use is equation 2. So I'm going to plug negative 1 in for x in equation 2. So let's see what that looks like. It says y equals 2x plus 1. So 2, instead of x, I'm going to put this negative 1 plus 1. So y equals negative 2 plus 1, y equals negative 1. So it says check your solution. Well, what's my solution? Right now I have y equals negative 1 and x equals negative 1. If I remember from yesterday and previous classes, my solution is the point that my variables intersect. So my solution to this system would be the point x comma y, or the point -1, -1. Well, we always want to check. So to check my solution, I'm going to plug this point into either one of my equations. Let's do equation 1. Equation 1 says x plus y equals -2. Well, -1 plus -1 equals -2. Does -2 equal -2? Yep. So this is my solution. This is the answer to my problem. That point is the point that these two lines intersect. Let's try another one. This one says y equals 3x plus 2 and 2 plus 2y equals 11. Well, if I look, equation 1 is already solved for y. I don't have to do any work to get y alone. So what I'm going to do is plug 3x plus 2 in for y in my second equation. So I have x plus 2. Instead of y, I'm going to put that entire piece, 3x plus 2 equals 11. So I have x plus, distribute that 2, 6x plus 4 equals 11. X plus 6x gives me 7x plus 4 equals 11. Subtract 4 on both sides. I get 7x equals 7. So x equals 1. That's the first piece that I just solved for. So now what I'm going to do is take x equals 1 and put that in to equation 1. I did not use equation 1 yet. I used equation 2 to solve for x. So I'm going to use equation 1 to solve for y. So equation 1 says y equals 3x plus 2. Ooh, that's a funky plus sign. So now put 1 in for x. Y equals 3 times 1 plus 2. Y equals 3 plus 2. Y equals 5. So I have my x and I have my y. So the point, my answer, is the point 1, 5. Well, how can I check my answer? I can put 1 in for x and 5 in for y in either one of my equations. Let's use equation 2, which is x plus 2y equals 11. Well, I have 1 for x plus 2 times 5 for y equals 11. Well, 1 plus 10 equals 11. Does 11 equal 11? Yep. So this is my answer, that point, 1, 5. Let's take a look at this one. It says, which letter should I solve for first? Well, the past 2 times, we've solved for x first and then solved for y. Well, if I look at this one, equation 2 already has x all by itself, and x equals 2y minus 6. So it doesn't matter which letter you solve for first. You want to solve for the one that's the easiest for you. In this case, x is already alone, so I can put this chunk in for x in equation 1. So I have 4 times x, well, x is 2y minus 6 plus 6y equals 4. Distribute the 4, I get 8y minus 24 plus 6y equals 4. Combine my like terms. I have 14y minus 24 equals 4. Add 24 to both sides. and I get 14y equals 28. If I divide both sides by 14, I get that y equals 2. So now I'm going to take this answer from equation 1 and plug it back into y in equation 2. So I have x equals 2 times y, well y is 2, minus 6. X equals 4 minus 6, so x equals negative 2. So I solved for y first this time, and then put it back into equation 2 to solve for x. My answer is still the same thing. It's still that point, x comma y, or negative 2, 2. Well, I gotta check my answer, so I'm going to check it using equation 2 because that's kind of a nicer number equation. It's a little less complicated. Well, equation 2 says that x equals 2y minus 6. So negative 2 equals 2 times 2 minus 6. Negative 2 equals 4 minus 6. Does negative 2 equal negative 2? Yep, so this is my answer, that point, negative 2, 2, meaning these two lines, if I were to graph them like we did the last couple classes, they would intersect at the point negative 2, 2. One more. We got some fractions in this one. Remember, fractions are friends, guys. Don't let them intimidate you. So I have 4x minus y equals 14, and then x equals 1/2 y plus 3. If they're fractions, I'm going to do the exact same thing. X is already by itself, and it equals 1/2 y plus 3. So I'm going to put this in for x in equation 1. So I have 4 times 1/2 y plus 3 minus y equals 14. Well, when I distribute that 4 times 1/2 is just 2. I'm left with 2y plus 12 minus y equals 14. 2y, take away another y, leaves me with 1y plus 12 equals 14. Subtract 12 on both sides, and I get y equals 2. Easy as that. I'm done with part 1. Now let me put y equals 2, or 2 in for y I should say, into equation 1. Equation 1 is x equals 1/2 y plus 3. So x equals 1/2 times 2, because 2 equals my y, plus 3. Well, 1/2 times 2, that's just 1, so x equals 1 plus 3, so x equals 4. So y equals 2 and x equals 4. So my answer would be that point 4, 2. Well, let me check my answer because I gotta check and see if this is actually the right answer. I'll plug it into equation 2. X plus 1/2 y, or x equals, 1/2 y plus 3. So 4 equals 1/2 times 2 plus 3. 4 equals 1/2 times 2 is 1 plus 3. Does 4 equal 4? Sure does, y'all. So this is my answer. This is the point that those two lines would intersect. So just like last class, now it is time for you to try some on your own. Enjoy the problems you have on the back of your sheet. And good luck. For those of you who don't have the problem, here's 1, 2, 3, and 4. Good luck, y'all.